Okay, so you can look with me at 8.5. 8.5 Foundations of Math 30. This is something we've done before. It's modeling data with a function. So it's determining a regression function. And we've done linear, we've done quadratic, we've done exponential, we've done logarithmic. And now we're going to do sinusoidal. We're going to find a sine graph that models the data. So again, in 8.5, we're going to be, whoa, excuse-moi. We're going to be looking at some data here, and we're going to be putting it into our calculator and asking the calculator to find a regression function, which of course is a function that models perfectly, or as perfect as possible, the data in question. So we're actually going to just work through one of your homework questions, which is question number 3. And I'm just going to try and get to it here. There's question number 3. Okay, and so we're going to put this in together. I'm just going to talk again briefly about about how to enter the data, and this is going to be a bit of a one more time instructional on regression stuff. So number 3, part of your assignment. Let's do this together. You should have a graphing calculator handy. Okay. While on her nightly walks with her dog, Kelly noticed that the moon appeared to be at different angles on different days. She researched the maximum altitude of the moon in degrees and obtained this data starting on April 1st. So April 1st would be, I guess, day 1, and then there's all the days there, and here is the angle of the moon, and I'm assuming that this is the angle sort of above the horizon, I suppose. Okay, so it looks to be higher in the sky here around here, right? Okay, and it's pretty low in the sky in the teens here. Okay. So we're going to put this data into our calculator. Okay, so we're going to graph Kelly's data, and we're going to estimate the period. Okay, so let's do that first. And if you are wondering again how to do that on the TI-83, we're going to get to stat, and we're going to hit enter. You're going to make sure list 1 and 2 or your first a couple lists are clear anyways. And then you're going to take a few moments and you're going to input the data. The first column should be the x values. So of course the x values are going to be the days. The responding values are going to be the degrees. That's what we measure, so that goes in the y. So take a few moments now to populate your graphing calculator, or wherever you're going to put these on your computer at home or whatever. All right, so once you've got your data in here, what you're going to want to do again is, now let's just go to the notes here. So to enter the data, if you are stuck, okay, so you hit stat, you hit enter, and you choose a list to put in your days or your x values, and a list to put in the percent degrees. I don't know why I've got percent there. Okay, to put in your degrees there. And that is going to be your y list. Let me see if I can fix that here. Whoops, come on now. Degrees. Your degrees. Degree values. Okay. So to plot the points now, so now we're going to hit second function stat, or second function y equals, I should say. We're going to clear the equations that are there. We're going to go up to plots. Right, and we're going to select the plots. The second function didn't work before, sorry. So these are on, second function y equals is on. Make sure your x list is appropriate and your y list is appropriate to the list that you put in there. Okay, so plots are on. All right. So the next thing we're going to do is that we don't have down here. You may have to change your window. You definitely will. So we go to window here now, and if you look at your data, the days or the x values range from, or the domain is really from 1 to 59. So I'm going to go 0 here, a little bit under the lowest one, and go to 62 or something, a little bit over the highest one. And we'll do the same for the y. So the lowest, I think, is going to be in the teens or something somewhere. We could go 0, I suppose, because we've got like 19, 16, that kind of thing. So we could go 0, it's not a big deal. And then the max, I think we've got in the 60s or something there. So I mean, shoot, we could we could go, well, it's going to be less than 90, right? Because if it's 90 degrees, that means it's right overhead, 90 degrees with the horizon. If you go more than that, then really you turn around and then it's an angle that's less than 90. So we don't have to go more than 90. So let's go y max 90. Okay. So if we graph this now, we should see our points. Wow, look at that. That's amazing. I like that. Okay. So we've got those points. I should put the window in here, adjust window. I'll do that here. Adjust window. All right. Now, to plot the regression function for the sine, as you can tell, if you had to make your own decision here, you would say, gee, that looks an awful lot like a sine graph. So you're going to now choose a function. So we're going to go to stat. Sorry, we're going to go to stat and then over to calculate, right? And we want to find the sine reg. So where is sine reg? Oh, there it is, way down there. Letter C, sine reg. And then hit enter. Okay? And now we've got sine reg, and now what you want to do is you, of course, want to tell the calculator, draw x values from list 1, comma, list 2 is your y values, and then we're going to put these straight into the y equals, which is again comma, and then vars, over to y vars, enter, enter, and then enter to get the calculator to do everything for you. So it's going to think for a second, right? And then you're going to have, oh, it needs some time. There we go. So if you were writing your equation, you would write y equals, here's the a value, 22.96, sine bracket. Now notice the format here. It's just bx plus c. There's no extra set of brackets there, I guess. So this is the way the calculator does it, right? The c is not really this number. That's just the c that's the number that goes in here. So there's no second set of brackets, right? So notice that for the calculator. So you plug all the values in there, and it should be in our y equals already. That's great, saves us a little bit of time. And then we'll hit graph again, and look at that. Here's the sine function. That's the curve of best fit. It's a sinusoidal regression, and that looks wonderful. So that's really the finished product there, okay? So I am going to, you know what I'm going to do is I'm going to clip the screen there. I'm going to put that underneath here so that we can look at that while we do our work. Okay, let's see. All right. Now I don't have any numbers or really any basis here, but at least we have the graph to look at while we look at this. So graph Kelly's data, estimate the period. Oh, we haven't done that yet. Estimate the period. Okay. So to find the exact period, none of this estimate stuff, but if you were just estimating, I suppose you could just go to trace and get a cursor and see if, oh, these are the points. So we want the function. There's the function. So just do a little down arrow till you list the actual sine function there. And you could scroll along and you could find, I guess, roughly what the max is. This isn't going to be exact, but you could do the trace function and say, hey, it's going to be about 63 degrees or so is going to be our max. And boy, 63 degrees. Did we have anything greater than 63? Oh, we had 63.1. Look at that. Is that right? Right, you had 63.1. So if you said 60 was the max, yeah, there's 63.5. So estimating the period, back to estimating the period, we're doing period, right? I gotta remember that. So the period is going to be from, a peak to a peak, right? Or a maximum to a maximum. This is not the maximum, okay? 62.7, 63. You could find the exact maximum, which I would strongly encourage you to do. I've done this in other videos, but second function trace, find the maximum 4. Put your cursor to the left of the peak, enter. Put your cursor to the right side of the peak, hit enter, and then hit enter again. And it'll give you the exact x value here. So we're looking for an exact x value for this peak. So 34.9, 63.0. Now, as far as the function goes, that is the maximum point, 63.0. Even though there is a point at one, that's above that, this is the actual graph. So that's okay. It's okay. But if we had 34.9, that's x1. And I know this is estimating, so you know what? I'll just do estimating. 34.9, sorry. 34.9 for one x value. And then what's another x value here? Well, can we go, you know what? I guess we're going to go back to, let's hit trace, get to our function. Let's go back to our previous, the peak just before that we know we can see on the calculator. And the trace function would be sort of a estimation right here at 8.57. All right, so my hotkey to unpause here is obviously a hotkey for something else. All right, so these are our two x values from peak 1 here, like this one, to peak 2, right? So this is the 8, this is the 34. So you do a little subtraction there, and you get your period, okay? So 34.9 minus 8.57 gives us about 26.3. So that's the period, 26.3, and that's going to be what? What's the unit for that? What are the x values here? Days, yeah. 26.3 days. Okay? So that's the estimate the period. Okay, we've graphed, yes, estimated the period, 26.3 days. Everyone see that? Just between any two peaks, or you can go between any two minimum points or whatever. Okay. Where did I get the 8.57? Just on my graph, I just kind of hit the trace, and I just found out what this x was right here at the peak. Okay, so you hit your trace button, and it's going to be, it says estimate, so you don't have to do the maximum. I did the maximum here. You could do the maximum here, get the calculator to give you an exact, and then you have an exact. Okay, explain why a sinusoidal function can be used to model the data. Well, it's periodic, right? It has maximum minimums. It's a very smooth curve emulating a sine function. Looks like a sine function, basically. C, determine the equation of the sinusoidal regression. Awesome. We've done that. It is, well, I could take a picture of that too, but it's y equals, right? And you put your 22 point whatever in there, 22.96. It'll come. Oh, wonderful. I think I just erased all my data. Okay. Anyways, on your calculator, just copy down the function. So somebody help me out here. 22.96 sine what? 0.23 x. Okay, so if you have a plus negative, don't write plus negative. That's okay. People do that. Don't write a plus negative if you can. Just write it as a subtraction. Thank you. And then what else? 0.21. And then what's the d value, or what do we have? Plus or minus something? 40.3. Plus 40.3? Oh, okay, perfect. If you do 1 or 2 decimal places, I'm totally fine with that. Okay? So there's your equation. Good. We've got C as well. What's the maximum angle of the moon? Okay, well, we did do an exact calculation on the curve of best fit. Now, it didn't seem to be as high as some of our data points. Okay? What's the maximum angle of the moon? So that's a tough question. Do we use the maximum on our line of best fit, or do we use one of our data points? What would you say? How would you answer this question? What's the maximum angle of the moon? Okay, you would use the data points. Why?
Because the line of best fit is just like the line that fits it best. It's not like super accurate.
Okay. You said the line that fits it best is just a best fit line. It's like a best guess. But if you actually have data points that are greater, you can't say a maximum less than something you've observed. Okay, that's a good point. That's a good point. We're using the line of best fit for most other things. What about, think about your points though. Did you collect all of the available data points? Or did this person? So what I'm saying is that, would there be a even larger number that maybe wasn't on this list? And why wouldn't we put that one down? Like, why wouldn't that be the actual answer? That's a good question. How many times does this show up? Let's see, 63.5 is the one that is in question here. This is larger than the stated maximum on the curve of best fit. So we could say this one, does it show up at all again? There was 63.1. Okay. All right, so it's a good question. It's a good question. I guess I would be okay. I think the first option would be to use the maximum in your line of best fit, unless you can see that you have a data point that exceeds that maximum. Then I think I would be okay with you saying, you know, but you'd have to explain that. You'd have to say the curve of best fit says that the maximum would be this 60.2 or whatever. But there is an actual data point at 60.5 or 63.5. So the maximum is 63.5. And you can go ahead and do that. That's fine. I'm okay with that. Okay? If it says use the regression function to determine the maximum, then you would definitely use the function, okay? But if it's unclear, then you can explain yourself, and I think that's good critical thinking. There's no real error in that, I don't think. Okay, estimate the altitude of the moon in degrees on day 100, okay? So we're gonna have to use our curve of best fit for day 100. So, shoot, I don't have it on my calculator anymore. But what you would do on yours, okay, and you guys will get this, you guys can do this, is you're gonna have to extend your window, first of all, to go past day 100. And you're gonna see that this graph is gonna keep going like this further and further. So I don't know what day I actually made mine go to, but this is going to keep going in this pattern like this, right? Okay. And then when we hit day 100, wherever that is, you are going to find out what the y value is. And again, this is just a guess. So on your calculator, you're going to turn it on. And you're going to go to window, and you're going to make your x max past 100. Go to 110 or something, 105, 110. And then type in x equals 100. Just your calculate, enter. And then I don't have a graph here anymore because my thing quit on me. But you would type in x equals 100 and hit equals. So what do you get? When x equals 100, what do you get? Sorry? 23.3, okay. So when x equals 100, we have 23.3, that would be the degrees on day 100, okay? To the nearest tenth. Yeah, and just so you guys know, the first decimal place is the 10th. The second decimal place is the 100th, okay? On your quizzes, I think only half of you actually either didn't read the question or understood that. So a 10th is one decimal place, a 100th is 2, okay? So fix that for next time. F, what is the first day in May that the altitude of the moon will drop below 30 degrees? Okay, so the first day in May, I think this was from April 1st, was it not? April 1st. So there's 30 days in April, right? So we gotta go something 31 or more. So we're looking at the data here after day 31, I guess. Right? So from after 29, I guess. Yeah, we'll say after 30. So when does it drop to, what does it say? 30 degrees? When does the moon drop below 30? So if we look at our data, it's probably going to be somewhere around day 44. Okay? But you would use your curve of best fit and you would determine that. Now, probably what you're going to do to be exact, okay, because we're given now a y value, right? So what you would do is you would, to find exactly this here, you would go, okay, so here's, this is about 63. So 30 is going to be right about here. You would draw a horizontal line, y equals 30, right? You would find where 30 is on your days, right? So remember, you're, yeah, we're about 60, so halfway through. So 30 is going to be right about here, right? And so if this is the point, let's say this is the point, then you're going to want to find the first time that it drops below 30. So that's going to be like over here. You're going to want to find this day where it drops below this line, first day. Okay. Now it may not be exactly like that. I lost my data on my calculator, but okay, the first time that it drops below that line, but the x value has to be greater than 30. Does that make a sense? It's making sense? Any questions? Okay, so that's example number 3. That's what this is all about. That's what this section is all about. The regression and using that graph to figure things out. Here's your assignment, and I'm going to give you some time to work on that. I will very quickly show you just the textbook here, and so here's question number 1. Well, actually, here's the key points, the summary. Take a moment to read that. Remember a couple things I just saw: interpolate and extrapolate. Do you guys remember those terms? Interpolate is within the data points that you find a value, and extrapolate is when it's beyond the collected data. It's way in the future or way in the past, or it's outside of the data points. That's the difference there. Okay? Okay, so here's just a snapshot of your textbook questions here. There you go, we just did 3. The Bay of Fundy. You'll have to wait if you didn't write them down.
1, 3, 4. 1, 3, 4.
Yellow knife. Yeah, 8 is, look at that shot. We're almost in that shot. We're just before that, yeah, aren't we? Well, a few blocks away. That's where we live. Question number 8. Well, we don't live at the ledge, but that was a shot of Regina. Did you not see that? No, but where we are right now, our school building is
Yeah, I
a
thought
few
you
blocks
said
south of this.
I thought you meant like that's where we live, as in we live at the school months away. So we don't live here.
Yeah, pretty much.
That's what I meant, yeah. Well, I'm living at the school these days. I don't know about you.
You just feel so low. I don't think I'll be able to go back.
All right, so that's that. All right. Any questions about 8.5 or your questions that you're working on so far?